Okay, we are going to formalize what we just explored. The equation of a line in slope-intercept form is y is equal to mx plus b, where m is the slope, and remember that that's the same thing as our rate of change. B is the y-intercept, and remember that the y-intercept is the same thing as the initial value. So in the equation of a line, if we look at the graph of it, B is the y-intercept, so that will be where the graph intersects the y-axis or the vertical axis. And remember, we also refer to that as our initial or starting value. And m is the slope, and the slope is our rate of change. In example 2, we're going to look at each one of these equations and identify the slope and the y-intercept. In part A, the slope is the number that multiplies x. Notice that the slope does not include the variable x. The y-intercept is the number that is added to negative 3x. So the y-intercept is 5. In part B, the slope is the number that multiplies x, so that is 2/3. And the y-intercept is the number that's added to x. Well, we see subtract 7, and remember that subtract 7 is actually like adding -7, so our y-intercept is -7. In C, our slope is the number that multiplies x, so that's that's positive 4/7, and the y-intercept is 1. In D, the slope is the number that multiplies x, so that's 2. Be careful, the order in which the terms are listed is reversed. And the y-intercept is the number that's added to 2x, so that would be 5. In some cases, the slope or the y-intercept may be hidden. In A, in example 3, the slope is hidden. It's that invisible 1 that sits in front of the x. So that could be, the equation could be rewritten as y equals 1x minus 3. And our y-intercept is the number that's added to x, so that would be -3. In B, the slope is the number that multiplies x, so that would be -3/5. And the y-intercept is the number that's added to -3/5 x. So that's going to be 0 because our equation could actually be written as -3/5 x plus 0. When you add 0 to something, you don't change its value. Okay, similarly in C, the slope is the number that's multiplying x. There's an invisible 1, so our slope is -1. The y-intercept is the number that's added. Nothing was added, so the y-intercept is 0. In D, the slope is the number that's multiplying x. Well, we don't see an x term, so the equation must be y equals 0x plus 2 because 0 times x is 0. And then if we add 0 to 2, we get 2. So if you don't see an x term, then the coefficient of the x must be 0. And the y-intercept must be 2 because that's the number that's added. If I want to graph a linear function in slope-intercept form, we're going to write the slope in fraction form. So for instance, if the slope is 2/3, then 2 is our rise and 3 is our run. And then I'm going to plot the y-intercept on the y-axis, and then start at the intercept and move vertically using rise and horizontally using run to plot a second point. I'm going to continue plotting those points until the grid is filled and then connect them. So in example 4, the equation is y is equal to 2x minus 3. So our slope is the number that multiplies x. That would be 2. The y-intercept is the number that is added to 2x. So that will be negative 3. So I'm going to start by writing the slope in fraction form. So m is 2 over 1 as a fraction. And then to plot, I'm going to start with the y-intercept. The y-intercept is negative, so we'll go down from the origin 3 units, and that will be our starting point. The slope is 2, so that means I will rise 2, go up 2, and go right 1, both positive numbers, plot another point, then go up 2 and right 1, plot another point, and then continue doing that same thing until the grid is filled. We can also go in the opposite direction, down 2 and left 1, down 2 and left 1. Then I'm going to connect that graph with a line. You may want to use a ruler, but a ruler doesn't necessarily mean that your graph is necessarily accurate. Accuracy is improved by plotting points all the way to the end of the grid. And we put arrows on the end since the line keeps going. In B, our slope is negative 3/4. That's already in fraction form. B is the number that's added to negative 3/4 x, so that must be 0. In order to plot the line, I'm going to start at the y-intercept of 0. So I'll plot 0 on the y-axis, and then I'm going to use my slope to plot other points. And I'm going to use negative 3 as the rise and 4 as the run. So that means from that point, I will go down 3 and right 4 to plot another point. And then down 3 and right 4 to plot another point. That will take me off the grid. I can also go in the opposite direction, up 3 and left 4, up 3 and left 4. Then I'm going to connect my points to plot the rest of the line and put arrows on the end. Our next example is the graph of y is equal to negative 4. Remember, there's no x term in this one, so our equation could really be written as y is equal to 0x minus 4. If you don't see an x term, the coefficient must be 0. So our slope is 0, and our y-intercept is negative 4. So when we write our slope in fraction form, that means 0 over 1, or 0 over any other number. And to plot points, I'm going to plot the y-intercept of negative 4. So on the y-axis, down 4 units. And then I'll go up 0 and over 1. Up 0 and over 1, up 0 and over 1, etc. And you'll notice that this forms a horizontal line. In the last example, the slope is that hidden negative 1 that is in front of x, or the coefficient of x, and our b value, or the y-intercept, is the number that's added to it, which is 2. In order to graph, I'm going to rewrite m as a fraction. So I'll write it as negative 1 over 1, and then we'll start plotting at the y-intercept. The y-intercept is positive 2, so we'll go up from the origin, and then plot other points by going down 1 and right 1, down 1 and right 1, until I've gone all the way to the end of the grid. Or we can plot in the other direction and go up one and left one, all the way to the end of the grid. Then we can connect the points and put arrows on the end.